Hello and welcome. My name is Eitan Suez, Technical Marketing Manager at solo.io. And this video is actually going to be a fairly elaborate step-by-step demonstration of a migration from sidecars to ambient mesh. We have a lot to talk about, and one of the focuses of this demonstration is the idea that we want to demonstrate the ability to do migration with zero downtime. And so I'm going to leverage some resources that you can find on the solo.io resources page, specifically a white paper by the title of Migrating from Sidecars to Sidecarless in Ambient Mesh. There is a sort of a companion set of instructions that are also available, which is what I'm going to be following myself here. And so the focus is how do we migrate to ambient, and there's a number of components we need to discuss, a number of considerations. We begin by thinking of an existing service mesh installation using Istio in sidecar mode. And so a couple of things to point out there is that in sidecar mode we have two options for how we implement the traffic redirection. One is through IP tables rules, which was the original mechanism. The Istio CNI node agent is the newer method. It has certain advantages from a security standpoint, and so it's recommended, but in ambient it's actually required. And so it's important, maybe as a first step, to make sure that we switch to using the CNI node agent even in sidecar mode, which would essentially eliminate one less dependency that we have to worry about meeting as we move towards ambient mesh. The other one is the new dependency on the Kubernetes Gateway API, and so it behooves us to perhaps consider translating some of the legacy, or I should say Istio-specific resources, such as virtual service and gateway, to using the Gateway API. Again, it's one less thing to worry about as we move towards ambient. And so that's a first step. So to help us understand the issues that relate to migration and how to perform a migration, we're going to use a sample application. Its topology is depicted here in this diagram. You see essentially external traffic coming in through an ingress gateway, and this could be a Kubernetes environment with Istio service mesh with sidecar mode to start out with, and then we want to migrate to ambient. And we depict here perhaps a very likely or possible scenario where you have multiple namespaces. Here we use the book info sample application, and we put the product page service in a separate namespace called front end, and the backend services, reviews, details, and ratings in the backend namespace. And we're going to apply a number of service mesh policies, authorization policies that restrict who can call product page, that the gateway can call product page, but no other workloads can. That will be a layer 4 authorization policy. And on the back end, a couple of authorization policies pertaining to who can call the details and rating service, but not just who. There's also some layer 7 policies in there. We'll look at that more closely as we implement this setup. And there's also a layer 7 traffic policy pertaining to the reviews service. So we were going to send requests to reviews v3. There are multiple versions of the reviews service, and so there's going to be a layer 7 traffic policy in the form of an HTTP route that needs to be implemented there. So reviews calls ratings, product page calls details and reviews. So you see sort of the layout of the call graph there. And it's important to think about how these policies are enforced initially through sidecars, but then how that enforcement point shifts to waypoints and z-tunnels, depending on whether we're doing layer 4 or layer 7 policies. And part of the recipe is sort of figuring out where you're going to need waypoints and how many waypoints you want to deploy and so on. All right, so we're going to get to work in terms of realizing that picture, and we start by provisioning a cluster. And so let's get to work. There's a lot that we're going to cover. We don't have a cluster right now running. We can go ahead, and I'm going to use a local K3D cluster. feel free to use anything that works for you. This is sort of something I'm habituated to. And so we're going to start with just a plain old cluster, and in a moment we'll have our cluster ready. kubectl config get contexts will validate that I have a cluster, a context. We can look at the namespaces. So I have now sort of a Kubernetes dial tone. So the next step is to then install Istio in sidecar mode. And we do this by first sort of adding the Helm repository, right, to our Helm client. And so that's done. And then the next step is to then install Istio. We're going to use Helm, and so Istio and Helm is deployed via several Helm charts. We start with a base Helm chart where we are going to install the Istio CRDs, and then we sort of continue. And notice here we pay close attention to using the Istio CNI agent, and instead of the default IP tables rules, and then we'll install Istio-D. So that will install Istio, and this is how you do it with Helm in 3 Helm charts. So we can now look at the Helm installations we have, base, CNI, and Istio-D. We can look at the pods in Istio system. We should see the CNI and Istio-D running. So that's all great. So we have Istio running. Next, we deploy a sample application. And for that, we're going to create 2 separate namespaces, just like we had in the picture, the front end and the back end namespace. And we're going to label them for sidecar injection. So I'm doing this for the front end first, and then I have a manifest that contains all of the different Kubernetes resources, service accounts, deployments, and services, and we'll do the same thing for the backend. And once that's done, we should be able to start looking at the pods in the front-end namespace, and we should again at this point be able to validate that we're running in sidecar mode, right? We've got 2 out of 2 containers, and that's because we labeled our namespace for sidecar injection. All right, so that's all good. We can look at the pods in the backend namespace, and I went ahead and deployed, I think, 2 replicas of most of the deployments, just to ensure zero downtime as we sort of roll out, restart any deployments in the course of doing the migration. All right, we're going to deploy also a curl image to the front-end service. And that will just aid us in just ascertaining that everything functions by making calls from inside the cluster to different services. So for example, we can call the rating service from the curl image, and here's a sample response. And we can also call the reviews service, and we might get responses from different versions of the reviews service. This could be reviews v3. Here's one from reviews v2. So there's some load balancing going on there. And then we can also call the product page service and grab for the title of the HTML response, and we see here the HTML title of that particular page. All right, so that's all good. So the app is deployed. We need an ingress gateway, and for that we'll use the Kubernetes Gateway API. And so for that we deploy the Kubernetes Gateway API CRDs. I'm going to use the standard channel here. And then we'll create a separate namespace for our ingress gateway. And because we're using the Gateway API, our gateway can be provisioned on demand. And this is a simple gateway that just exposes the port 80 for HTTP traffic. We're using the hostname bookinfo.example.com. So nothing particularly realistic here, just a simple ingress gateway will do. And then the routing rules captured as an HTTP route to the different endpoints that make up the application. So whether it's the API endpoints or the login, logout, or the product page, or the static resources. Here we go. So we now have a route. We should be able to verify that. We should be able to, maybe what I'll do here is open a couple of panels, and we'll create an environment variable called gateway IP, which captures the IP address of that particular gateway in that namespace. There it is, 192.168.117.2. All right, okay, here's where we overlay the mesh policies. We begin with authorization policies. Now the first one here restricts who can call the product page service, and who is defined by that principle there on lines 14 and 15, which is the gateway that we just created. And so that's a layer 4 policy. The other two policies are somewhat similar, but also include a layer 7 component. It's not just who can call the rating service, in this case the review service can call it, no one else, but we only allow HTTP operations get in post. And the details service is likely protected. It can only be called by the product page service, but only HTTP GET requests. And so we can apply these policies one after the other. Here's the product page authorization, the ratings authorization, and the details authorization. And we can perform some kind of basic check to see that these policies are now sort of in play, in effect, right? We can try to call from our little curl image the product page service, and we should receive a 403 forbidden, and that's because again, only the ingress gateway can call that particular service. And if we were to try to do the same thing to call, say, the rating service, we're not the review service, so we should get an RBAC request denied, or access denied rather. And again, because we're calling the details service not from the product page service, we also get an access denied. So it all seems to work fine. Now notice when I actually try to call the product page service from through the ingress gateway, in this particular case it works, right? We get a 200 response, so that's all good. All right, and there are other checks for authorization that I'm not performing here, so keep that in mind. For example, we could try some of the layer 7 policies, the fact that maybe we can't do a post to the rating service, but we can do a get, for example. Or is that what it was? Yeah. No, the detail service rather. Okay, so let's carry on. There's also a traffic policy. This is a layer 7 traffic policy, and we can sort of see if I run this in a loop. Let me run this in a loop. This is a request to our application, and I'm grepping for reviews to see what version of the review service actually handled my request. So product page calls the reviews, and there are 3 versions. If I put that in a loop, you could see that we're definitely load balancing across multiple versions, version 1, 2, and 3. So that's all great. Here's a route. This is an internal route, a mesh route that defines that any calls to the review service should be directed 100% of requests to reviews v3. We could have done some kind of mix, but we chose to just send everything over to v3. And when we do that, you should notice that immediately after applying that policy, all requests are now handled by reviews v3. So that's another layer 7 policy that we have in play in our setup. So our setup is now complete. We've realized this picture. This is all running in sidecar mode, and we're about to begin on the migration part. So let's talk about the migration plan for a moment, right? We need to think about what's layer 4, what's layer 7. I've been careful to call out, as we look at different policies, what actually falls under which category. And so the questions we typically need to ask ourselves is, where do we need waypoints? And how many waypoints do we want? And that's there's a little bit of a sizing game going on here. But typically, for related services, it makes sense to deploy a single waypoint that's sort of scaled or auto-scaled on its own, right, as necessary to support whatever related services for which it sort of proxies and implements our mesh policies. And so when we think about what we have in our picture, we go back to our little setup here. A lot is going on inside this backend namespace, right? There's a traffic policy in front of reviews, authorization policies. Those are all layer 7 in front of details and ratings, so it makes sense to put a waypoint there. When we look closely at the authorization policy on the product page service, we realize it's a layer 4 authorization policy, and so it does not require a waypoint. That can be handled by the Z-tunnel layer 4 proxy that's part of Ambient. All right, so that's a little bit of the thinking that we have to do as we sort of begin to implement a migration. So here I have an outline. We'll need to deploy a waypoint, we'll need to retrofit authorization policies, and we'll need to eventually switch the workloads to be part of the mesh, remove the sidecars, and use the conventional labeling of services and namespaces to indicate that we want ambient in the data plane. Now, to help us with that, we're going to use the migration tool. If you haven't looked at the migration tool, solo.io actually no, this is an open source, ambientmesh.io, talks about this migration tool, which is free and is assisting us with migrations. And I'm going to be using and leveraging this migration tool in the process of doing the migration. And this involves essentially downloading a CLI called glue, and you can just run the command glue ambient migrate to get feedback on how our migration is going. And so that's a little bit of information. Let's go ahead and maybe I'll open a separate tab, or maybe I'll do this here. Yeah, I think this is good enough. Maybe I'll just clear a little room for myself here. So let's try this, glue ambient migrate, and we look at the output. And the output falls into multiple categories. So we see here, for example, prerequisites is something that this migration assistant help us with. So it notices that we're using the CNI agent, so the CNI compatibility is good. The Istio version compatibility is good. See a type, no typo. Multi-cluster usage, virtual machine usage compatibility, Spire. So there's a variety of different dimensions or aspects of compatibility that are verified here. The next phase is called the cluster setup, and here we see some of our errors. So we have Istio installed and running in not in ambient, but in sidecar mode, and the profile is not the ambient profile, and we need to switch to the ambient profile, and that's what we're told here, in order to enable ambient mode. It also notices that we don't have the ztunnel component of ambient deployed. That's a separate Helm chart, so we'll need to do that as well. And then finally, this is interesting. This is something that you may or may not be aware, but a restart is actually necessary to enable the HTTP-based overlay network environment tunneling protocol for sidecars. So we need to restart the sidecars to support ambient mode as well. And so those are some of our preliminary cluster setup requirements that we need to satisfy in order to make all this work. So I like to run this command and wrap it in a watch command so that as I make changes, maybe some of these things will actually update to have check marks instead of red X's, and so we can watch for that. All right, so let's go back to our little sort of to do here. Our first step will be to upgrade Istio and to address the very subjects we just discussed or outlined a minute ago. But one thing you ought to know is that there is a particular relevance here of solo.io's distribution of Istio. And this has to do with interoperability between sidecars and ambient mode. There are nuances that we have to think about. For example, we have mixed sidecar and sidecarless workloads. It is not guaranteed that with open source Istio, requests from clients that use sidecars will actually go through waypoints to services that are in ambient mode, and so that could mean that request could be bypassed, and we typically define a layer 4 authorization policy to prevent that. But nevertheless, that interoperability is provided by Solo's distributions of Istio, and so it's important to point that out. So we can use OSS Istio to do our migration, but if we care about the situation where we have mixed workloads, clients that use sidecars, that requests or policies are enforced by the waypoint, we need this distribution. And so notice that the way we will upgrade Istio is not only to set the profile ambient, but also to download the Solo distribution of Istio, and that's done through a tag. You'll see that the version will be Istio, whatever version number -solo. When we look at what we have installed, we'll be able to see that. And so we proceed by installing or upgrading the CNI. Let's go ahead and do that. Helm upgrade Istio CNI. And then we'll also upgrade Istio D, that's the Istio control plane. And as we do that, the ambient mode enabled turns green on the right hand side. Now we haven't yet installed the CNI, that's the next step, the ztunnel component. And so we'll do that. We'll do a Helm install of ztunnel. This is the Solo Istio distribution of ztunnel, and as we do that, we'll see that daemon sets deployed turns green on the right hand side. So it's very useful to have the migration assistant to help us and guide us along the way in terms of helping us determine what our next step ought to be. All right, so the next step we're told is to restart the pod after setting the profile to ambient. We've set the profile to ambient, so let's just restart the pod. So what do we need to restart? Maybe before we do that, we can also look at our Helm charts or Helm releases and notice that we have the Istio D126.3-Solo, for example. These are the solo distributions of Istio are in play. And if we look in the Istio system namespace, we'll see ztunnel, Istio D, and Istio CNI are all running. So that's great. All right, so let me fast forward. Here we are at the juncture where we need to restart some of our deployments. Now here at the top, you'll see requests are being made in a loop about 2 seconds or so to my system to demonstrate that we really have no downtime, and this is primarily because I've got 2 replicas of every deployment in play, so we can restart our deployments on the back end, and we can restart the deployments in the front end namespace. And as we do that, we should see that sidecar support in ambient mode, which is currently failed, as these pods get replaced, we'll see that these checks will now succeed and no failures are reported vis-a-vis that particular checked item. All right, so the next step is a phase called deploying waypoints. We're going to need waypoints, and the migration assistant has noticed that we have authorization policies for details and rating service, but not product page, because that's a layer 4 authorization policy, which is going to require a waypoint. We also know a waypoint is required for the review service for the traffic policy, which is not pointed out here, and that's something that will probably be fixed in the migration assistant's detection logic before long. The issue's already been reported. So let's go and work on that. What do we need? So notice that the actual advice here says that a recommended waypoint has already been written for us, and that's kind of cool. So we can cat temp istio migrate recommended waypoints. And notice this is actually nothing out of the ordinary here. The Istio CLI actually allows us to deploy this waypoint. So this maybe is an equivalent alternative, which I tend to prefer. I kind of like this the help that the Istio CLI provides. It has a variety of waypoint subcommands. One is waypoint apply. We could also do a waypoint generate to generate this very gateway resource. So notice that waypoints are implemented using the gateway API, using a particular gateway class called Istio waypoint. And so we're going to deploy a waypoint to the backend namespace, and that waypoint we want to associate to all those workloads in the backend namespace, which will be a separate step. So the first step is to deploy the waypoint, and as we deploy the waypoint, you'll see that phase, deploy waypoints, goes green. But we still have the warning that we have not yet associated that waypoint with the particular workloads or services that need it. There's also another issue here, which is a need to translate our authorization policies. And we can look at the recommended policies that have been written to us for us by the migration assistant to really see what that's all about. So if we do a bat temp istio migrate recommended policies, we'll see that our authorization policy was detected but also translated for us into 2 separate policies. One is a layer 4 authorization policy that allows only the waypoint to talk to the detail service, and you'll see there's going to be another one below it that does the same thing for the rating service. But then that layer 7 policy basically says that the waypoint should only allow a proxy request to the detail service if it comes from the principal product page. And so it's kind of a 2-part authorization policy. And here you see the same thing for the rating service. In this case, the source principal going through the waypoint is the review service, and the operations or the methods, the HTTP methods that are allowed are get and post. So we're going to essentially the translation of the authorization policy for ambient has been performed for us, and now all we have to do is kubectl apply -f recommended policies. And as we do that, the phase migrate policies is now complete. We're still not using our waypoint in the path to request to those services. And so we need to do that next. And we can either label the services, which is the advice given to us here, label service-n backend details or ratings, with the special label use waypoint equals waypoint name, which in our case is waypoint. If we look at the gateways in the backend namespace, you'll see the waypoint is there. We can also do Istio waypoint list to see that waypoint in the backend namespace. There it is. So how do we associate it? We can label the services. I'm going to choose to label the whole namespace, which will basically is a simpler way of saying all services in that namespace should be proxied by that waypoint. And so we can k-label ns backend use waypoint equal waypoint. And as we do that, you'll see that that phase use waypoint is now complete. Now we're told that we can, since we've switched to or migrated our authorization policies, we can delete the older ones. So k delete authorization policy backend. I think there was a ratings auth that was our original authorization policy, and a details auth. So that's done. And now we're almost at that final step, which is to remove the sidecars. Okay. So if we look again at our pods in the backend and front end namespaces, notice that they all still have sidecars, and we need to remove them. And not only do we need to remove them, we need to change the convention. Instead of using sidecar injection, we want the data plane mode to be ambient. There's labels for that, and we're told what labels are to be: Istio injection minus and Istio data plane mode equals ambient. I'm going to go ahead and copy that from my instructions here. We're going to do them as two separate steps. So the change of the labels is really pertains to the next is essentially a passive sort of action. It doesn't, nothing is actually caused other than the removal or addition of the label. And we're going to start with the backend services, and I'm doing this on purpose because as I restart the deployments in the backend namespace, all the backend services, details, ratings, and reviews, we are now going to be in a situation where we no longer have sidecars on the backend, but we still have sidecars on the front end. And it's important to think about what that means, because a client that still uses sidecars will try to call a service that no longer uses sidecar, and that interrupt is not supported in open source Istio. But because I'm using the solo.io distribution of Istio, it actually functions just fine. That requests are routed through the waypoint, and all of these authorization policies are still in play and they still function. We can test that, right? So if we look again at our pods in the backend service, they're now in ambient mode. And in the front-end service, we're still using sidecars. And there are ways to actually find that out. For example, if I do a curl to the bookinfo application and look at the details section, bookinfo details, that request actually succeeded. So the application continues to function, and that's because I'm using the solo distribution. Were I to use the open source distribution of Istio, you'd see that the layer 4 authorization policy would still be in play, but not the layer 7 one, and so that request would have been denied. Anyhow, long story short, what we need to do here is make sure we use the solo distribution of Istio to ensure continued support, especially if we have an environment where we know that different teams that are responsible for different services have different schedules for migrating their services, and this gives us the lenience we need. So we can continue to function just like this, even though our migration is not complete, because all our mesh policies function because we have that sidecar to ambient interop. All right, so next step is to simply migrate the front-end services. And again, we do this by replacing labels and restarting our deployments, which will remove the sidecars. Now everything will be running in ambient mode, and our migration now is going to be complete. That's it. So here we've done it. We've actually migrated from sidecar mode with a variety of mesh policies, traffic and security policies, in this sort of local environment with no downtime thanks to solo.io's distribution of Istio and this migration assistant, which you see here, which really helps us sort of step by step determine everything that we need to do in order to carefully migrate from sidecars to sidecarless. All right, and with that, I'll conclude this demonstration, and we'll see you in another video. Thanks. Bye.